So you finally understand what a limit means, but now you'd like to explain it to a friend. And you excitedly try to explain it to your friend, but you recognize that your friend is looking at you as though you're speaking another language. As it turns out, you are. And what you need to do is to be able to teach him that language. You think about it and you realize that each language has its own notation. So the first step in helping your friend is to teach him the notation of this particular language so that he can understand exactly what you're talking about when you describe limits. Let's think about how that thought process might have gone. Maybe we might have thought about the example where previously we were approaching on a function a particular value from the left-hand side. And perhaps we thought about how to express this. So we might have said, suppose that our function, the black part that we started out with, that particular graph, can be represented by the function f of x, whatever f of x is. So f of x represents that black function that we graphed initially. So how can we represent that we're approaching a particular value? In fact, we're approaching where x is right here because we want to get to this point. How can we represent that for this particular function? Well, we could say that the limit as x approaches this value here, which in this case is 3, but we're approaching it from the left-hand side. Notice that all the numbers, or the majority of the numbers on the left-hand side, are negative numbers. So if we're approaching from the left, we're going to put a minus sign right next to it. So this is what we mean when we say we're approaching the function or approaching a value of the function from the left-hand side. In this case, remember that the left-hand limit was this number here. That was what we talked about in the last video. So this limit, this left-handed limit, was -1. We could also approach the same value, but we can say we're coming from the right-hand side. And if we approach from the right-hand side, we're basically going to end up stopped in the same location. But how do we represent that? Notice that all of the values that all of the x values that we're looking at as we approach are positive values. So when we approach from the right-hand side, we're going to say the limit as x approaches, we're still approaching 3, but coming from the right, we're going to put a little plus right here. So as we do the limit of the function f of x as x approaches 3 from the right, that's what all of this means right here. And notice that as we approach from the right, we still end up at this -1 value. So what we said in the last video was that if the limit from the left let's correct that. So what we said was that if the limit of the function as we approach from the left side of our indicated value, which in this case is 3, is equal to a particular value, and if our limit of our function as x approaches 3 from the right-hand side is the same value, whether we approach from the left or we approach from the right, if we end up with the same value, in other words, if the two limits are equal, then we're going to say that the limit exists. So to make it simple, basically, whenever this happens, whenever the left-hand limit equals the right-hand limit, instead of using these individual signs here, since we end up at the same number anyway, we just talk about the limit in general. So if we're talking about the limit in general from both sides, then we don't need to put a plus or minus next to the 3. So we're saying that the limit in general is going to be -1. Let's use our limit notation to describe the following function. First, let's understand the function. What we have here is a neighborhood. So we have one neighbor that's going to live on one side of the fence, and we have another neighbor that's going to live on the other side of the fence. And that orange dotted line is going to represent the fence. So where would each of these live? Notice that we're saying here that x, in the green portion, x is greater than 1. So x is 2 here, 3 here, 4 here, etc. So all of this right here, that side of the graph would represent where x is greater than 1. So that means that our function x squared is going to live on that side of the fence. Our function 5x is on the other side of the fence where x is less than 1. So x is less than 1 here on that side of the fence. So that means that 5x is going to live on that particular side. So that's where we get those two pieces for that particular graph. But let's use our limit notation to describe what's going on here. Suppose that we wanted to describe the limit as our function has x values going to 1, but let's say from the right. What do we put here to show that it's coming from the right? We'd have to put a plus sign. So what exactly would this equal? Well, if we're coming from the right, this is where we're starting, and we're going to continue down along until we reach our stopping point close to 1. So it looks like when we get close to 1, we're going to be stopped at a function value of exactly 1. So this particular answer is going to be 1. So the limit as f of x goes to, the limit as x goes to 1 from the right for our function f of x is going to equal 1. So if we want to approach from the left-hand side, we're coming from this direction. We're going to get closer and closer to where x is 1 along that dotted line. So it looks like our function value here is going to be something close to 5. So how do we describe that? We say the limit as x goes to 1 from the left of our function f of x is going to equal 5. Can we describe a general limit here? No, because the left-hand limit does not equal the right-hand limit. They're different values. So what we would say here is that for the general limit, if we want to describe the limit of our function, instead of using a plus or minus, and we just said going to 1, we would say that this limit, this general limit, does not exist. Could we describe this limit using limit notation? And does the limit exist in this case? So think about that for a second. Pause it. Think about how you would answer that, and we'll talk about it together. So let's say that we wanted to describe the left-hand limit. We would say the limit as x goes to 1, put a minus sign here to indicate from the left of our function, so x to the 4th minus 1 over x minus 1, and we have it graphed over on the right-hand side. So in the future, we're going to talk about how we could use substitution to answer this, but for now, let's just go ahead and answer this question using the graph. So on this side, which is the left side, if we kept going and we got closer and closer, by the way, 1 is here. This is where we're going to stop. So as we get closer and closer to that particular x value, it looks like we're going to have a value that is close to 4. So we would say that in this case, that our left-handed limit is equal to 4. So let's talk about the right-handed limit. So if we approached from the right-hand side, as we got closer and closer and closer and closer to our stopping value, what's going to limit us, again, it looks like we're getting closer to 4, but from the other direction. So we would say that the limit as x approaches 1 from the right of our function is also 4. So what can we say about the general limit? Does the general limit exist? What do you think? So yes, it does. So we can say instead of using that plus or minus, the limit as x goes to 1 for our indicated function does exist, and because the left and right hand limit are the same, we know that's true, and that limit is equal to 4.